In this problem, they said a chemical plant produces acetic acid by the oxidation of ethanol in the reactor. So the reactor contains 100 gram mole per minute of ethanol and 1000 gram mole per minute of dry air. For this passage that I highlight, we can conclude that 30% of ethanol goes to product stream. 30% reacted. And we also know that the molar ratio of acetic acid to carbon is 3:1. Look at the first question. The first question is find the molar flow rate of all components at the product stream. At the product stream. Take a look at the chemical reaction here. I will set the first chemical reaction as a sine 1. And the second chemical reaction as sine 2. First of all, we have two-valent chemical reaction. Two-valent chemical reaction, the coefficient of the left side and the right side must be the same. So look at the first chemical reaction equation first. Okay, look at the C. We have two, right? Two on the left and two on the right. Okay, what about H? The hydrogen one. Okay, on the left we have H like 6 and we have on the right like 6. Okay, what about O? On the left we have 3 and on the right we have 3. Okay, it's the same. What about the equation 2? Okay, look at the C. C on the left side I have 2. C on the right side I have just 1. So I will multiply by 2. Okay, what about H? On the left side we have 6. On the right side we have only 2. So I will multiply by 3. Okay, what about O? And O, on the left side I have just 3. And on the right side I have just 7. Okay, so I will multiply by 3 here. Okay, all done. Sorry. Okay, so then draw the diagram to see the pictures clearly. As I said before, the reactor contains ethanol and dry air. So the ethanol is 100 gram mole per minute. So the feed of ethanol is 100 gram mole per minute. So in mass balance with chemical reaction, we have to do in mole fraction. So for the ethanol is 1. And for the dry air, we have nitrogen and oxygen. It's fixing. Nitrogen is 79% and oxygen is 21%. So we have to do in mole fraction too. Nitrogen is equal to 0.79 and oxygen equal to 0.21. For the product, we already know the product of ethanol is 30. So I will put it 30 here. And I will set the acetic acid as 3x and carbon dioxide as x. I will set the basis as F equal to 100 gram mole per minute. So this time I will name it as burner. In F here and dry air here. So the out is P stream here with reaction. So I will do the ethanol mass balance first. In odd out at gen odd con equal to accumulation. Con is 0. Accumulation is 0. So in is this here mole of ethanol in F stream minus mole of ethanol in P stream plus nu 1 psi 1 plus nu 2 psi 2 because ethanol is already in both of chemical reaction equation. So we can write it like this. The component of ethanol in F stream is 1. And the F stream is 100. Minus, we already know, right? The ethanol in P stream is 30. Plus, the new one for reactant is decreased, right? So it's gonna be minus. And the product is increased, it have to be plus. For new one, it have to be -1. And new 2 is also have to be -1. Okay. -1 and -1. So we can rearrange it to psi 1 plus psi 2 equal to 70. The next component, I will do CO2 mass balance. In odd out adjacent odd count equal to accumulation. In is 0. Out is mole of CO2 in P stream, right? And the new 2, look at the equation again. The new 2 is positive 2, right? Here. So we write it like this. Rearrange this. Psi 2 equal to x divided by 2. Next, I will do the acetic acid mass balance. In is 0. Out is a mole of acetic acid in P stream. Plus new 1 and psi 1. Because look at the equation again. Okay, so for the acetic acids in the product is increased, right? So we can write that 1. The nil is 1. Okay. And the mole of acetic acid in P stream, we set it as 3x here. So we got psi 1 equal to 3x. Okay. So let's back it to ethanol mass balance. Psi 1 is 3x plus psi 2 is x divided by 2 equal to 70. So we got x equal to 20. Okay, now we got x equal to 20 divided by 2 is 10. We got psi 2 is 10 and psi 3 is 60. Okay, now we got the psi 1 and psi 2 already. Let's look at the O2 mass balance. O2 mass balance, we do the same thing. In odd out adjacent odd count equal to accumulation. Mole of O2 in dry air minus mole of O2 in P stream plus new 1 psi 1 plus new 2 psi 2. Okay, let's write this. The component of O2 is 0.21 times by dry air stream. Okay, so we got psi 1 is 60 and psi 2 is 10. So we can got mole of O2 in P stream equal to 120. We do the same thing as O2 mass balance. In odd out adjacent odd count equal to accumulation. In the mole of N2 in dry air. Out the mole in N2 of P stream. They don't have any generation in chemical reaction here. So we set that as 0, equal to 0 here. So we got mole of N2 in P stream equal to 790. So the last one is H2O mass balance. In odd out adjacent odd count equal to accumulation. In is 0. Out is mole of H2O in P stream. And the new one, look at the equation again. The new one of H2O is positive 1. And the new 2 of H2O is positive 3. So we can put it right here. So we can got mole of H2O in P stream equal to 90. We can write it like here. 120, 90, and 790. Okay, so x we got is 20, right? From here. And for acetic acids, we can sub the x is 60. So the total of the head stream, we got 1,110 gram mole per min. That's it. For 6.2 question, easy to understand. We need to categorize the given substance into condensable liquids and non-condensable gases. Okay, for a condensable component in liquid phase, the ethanol is 30, the acetic acid is equal to 60, and the water equal to 90. So the molar volume of condensable liquid equal to 120 gram mole per min. And for non-condensable gases, we have CO2, oxygen, and nitrogen. CO2, we have 20 gram mole per min, oxygen, 120 gram mole per min, and nitrogen, 790 gram mole per min. So the molar volume of non-condensable gases is 930 gram per min. So here is the final solution. Thank you for listening.